Okay, so quick review of Chapter 7. Alright, what do each of these symbols represent? We need to be familiar with each of these items, and we should be comfortable that these first come from populations or talk about populations. Right, the next ones, right, come from samples, and these last ones come from sample distributions. Okay, so we also need to be familiar with what they each represent. Right, so mu x bar and mu x bar talk about means. Okay, sigma s or sigma x s sub x to talk about variable x, and over here we could say mu sub x, right? So sigma s, right, and sigma x bar talk about standard deviation. P, and sometimes written as P naught, P hat, right? So P, sometimes written as P naught and P hat. This goes to a proportion, right? And N talks about your sample size. Right, of course, another one of these in standard deviation would be sigma of P hat. Alright, so mu sub x is the population mean, x bar is the sample mean, mu sub x bar is the sample distribution mean. Sigma x, population mean, s sub x, sample mean, sigma x bar is sample distribution, standard deviation. So standard deviation of the population, standard deviation of the sample, standard deviation of the sample distribution. And over here, standard deviation of the sample distribution, this for proportions, this for means. Alright, so once again, over here, SDSP, over here, SDSF. Okay, and with those similar ideas, P naught is population, P hat is the proportion, okay, and N is the sample size. Alright, so over here, the other one that we forgot was mu of P hat, and same thing, that's the mean of the sample distribution of sample proportions. Okay, how do we compare and contrast the distributions of P hat and X bar? Well, here's how we do it. Let's send P hat this way and send X bar that way. Alright, so for P hat, I could calculate a z-score. That z-score would be P hat minus P all over the square root of P times 1 minus P all over N. Alright, and sometimes you will see this written with the P naught, a little subscript of 0. Okay, and what do we need for this? We need to have random samples or experiments. Alright, it needs to come from a random sample or random experiment. We have the 10% rule, which is that N needs to be less than or equal to 0.10 times N. Right? So the sample size needs to be less than 10% of the population, and we also have the large counts condition, which is that N times P must be greater than or equal to 10, and N times 1 minus P must be greater than or equal to 10. Okay. For X bar, what do we have? We do have a z-score, though more commonly we'll use something else called a t-score, right? And for that z, for that z, we're going to have x bar minus mu all over sigma over the square root of n. Okay, and once again for this, we're going to have things come from a randomized sample or experiment. Okay, randomized sample or experiment, and we're also going to be conditioned on the 10% rule. Alright, so n needs to be less than or equal to 0.10 capital N. Sample size needs to be less than 10% of the population. And for this one, we need to have a large sample. In other words, n is greater than or equal to 30, or we need to come from a normal variable. Alright, the data needs to come from something that's already normally distributed, in which case the sample size does not matter. Right, so our sample distribution is sample proportions, our sample distribution of sample means. Alright, so S, D, S, P, and over here S, D, S, M. Very important that we understand those